Welcome to This Explainer. Today, we are diving deep into a massive launch, Google's Gemma 4. This is a highly anticipated family of open-weights AI models, and it's built from the absolute ground up to maximize something they call intelligence per parameter. So whether you're just a developer tinkering on a fun weekend project, or you're an enterprise looking to deploy at massive scale, you'll definitely want to stick around. This release is basically designed to completely rewrite how we think about running AI locally.
To really grasp the sheer impact of this launch, we actually have to start with a number: 400 million. That's how many times the previous Gemma models have been downloaded by developers all around the world. It is literally staggering. That adoption has created this vibrant, bustling ecosystem of over 100,000 custom variants. So, Gemma 4 isn't just dropping into an empty void. It's a massive, massive upgrade launching into a community that is completely hungry for it and has already proven exactly what open models can really do. Okay, let's map this out. First, we'll officially meet Gemma 4. Then, we'll check out the super efficient edge models, followed by the heavy hitters built for your PC. After that, we'll crunch some numbers on hardware and memory planning, and finally, wrap things up with the Apache 2.0 ecosystem. All right, part 1, meet Gemma 4. So the foundation here is incredibly strong. Gemma 4 is leveraging the exact same world-class research and tech that powers Google's flagship Gemini 3. The whole point of this model family is to hand you the absolute most capable open AI you can possibly run on your own hardware. The goal here isn't just to boast about a giant parameter count. It's all about pushing the absolute physical limits of advanced reasoning for every single byte of memory you give it. And wow, the jump in core capabilities is wild. For the larger models, we are talking about a massive 256K context window. To put that into perspective, you could pass entire massive code repositories or multiple thick volumes of text in a single prompt. Plus, you get native audio and video processing, support for over 140 languages, and built-in function calling for autonomous agents. Oh, and they finally introduced native system prompt support, which is a total game changer for getting structured, highly controllable conversations right out of the box. Let's move on to part 2. Edge AI and the small models. Now, these small but mighty models, specifically the E2B and E4B sizes, are honestly an absolute game changer for mobile and IoT devices. They are engineered from scratch for maximum compute efficiency. We're talking running completely offline, preserving your battery life, and delivering near zero latency. And yeah, they natively process audio and vision in real time. You can quite literally deploy these right now on a Google Pixel, an NVIDIA Jetson Nano, or even a basic little Raspberry Pi. But how are they pulling off that kind of efficiency? Well, the E in E2B and E4B actually stands for effective parameters. They use something called per-layer embeddings, or PLA. Think of it like this. Instead of stacking up bulky traditional layers that just gobble up your device's limited memory, PLE gives every single decoder layer its own tiny embedding for each token. It acts like a lightning-fast lookup system, which totally maximizes parameter efficiency for on-device deployments. All right, part 3, PC power and the large models. So while those small models are all about extreme mobility and saving battery, the 26B and 31B models go in completely the opposite direction. These are built to turn your standard workstation into a full-blown, local-first AI server. They're optimized specifically for consumer GPUs to give you frontier-level reasoning capabilities. This is exactly what you want for hypersmart coding assistants, deep IDE integrations, and running complex multi-step agent workflows. And this dense architecture means Gemma 4 severely outpunches its weight class. We're talking out-competing models literally 20 times its size. Just look at the Arena AI text benchmarks. The 31B model hits a score of 1,452. That secures it the number 3 spot globally for open models. Number 3. The 26B model is right on its heels at 1,441. Both of these completely obliterate the previous generation's score of 1,365. This is top-tier intelligence, byte for byte. Now, to keep inference speeds blazingly fast for things like real-time coding assistance, the 26B model uses a mixture of experts, or MoE, architecture. This is fascinating. When it generates a response, it doesn't use the whole brain. It only activates a fraction of its network, just about 3.8 to 4 billion parameters per token. That keeps the speed incredible. But, and this is a big but, it's totally vital to remember that all 26 billion parameters still have to be loaded into your memory so the model can rapidly route between them. Which brings us right to part 4, hardware and memory planning. I'd honestly recommend pausing for a second to review these exact memory requirements. Matching the model size you want with the right quantization is the absolute secret sauce to fitting these into your available VRAM. For example, if you want that full 31B model in pristine 16-bit precision, you're going to need nearly 60 gigs of VRAM. But if you drop that to 4-bit quantization, that same 31B model suddenly only needs 17.4 gigabytes. That makes it highly accessible for totally standard consumer hardware. What a difference, right? Now, let's ground this in real-world usage. Those estimates we just talked about, they only cover the static base weights. That's step 1. Step 2, you have to plan for additional dynamic memory for your KV cache. This cache grows larger the longer your prompt and response get, especially if you actually try to fill up that massive 256K context window. And step 3, if you plan to fine-tune the model yourself, prepare for some drastic VRAM increases depending on your exact framework and batch size.
Okay, finally, part 5, the Apache 2.0 ecosystem.
It's super clear Google listened to community feedback here. As Hugging Face CEO Clement Delang so enthusiastically points out, releasing Gemma 4 under a commercially permissive Apache 2.0 license is a massive milestone. This license is everything. It hands you complete digital sovereignty. You get total, unapologetic control over your data, your infrastructure, and your models, so you can build freely and deploy securely.
And because of this totally open approach, we are seeing incredible day-one availability. This means you can start integrating Gemma 4 today using the tools you already know and love. Whether you're pulling weights straight from Hugging Face or Kaggle, spinning it up locally on Ollama or LM Studio, or even scaling way up to massive production workloads on Google Cloud Vertex AI, the tooling is quite literally already there, waiting for you. So, we've seen how Gemma 4 scales all the way from those ultra-efficient E2B edge models that can run on a standard smartphone straight up to the 31B Powerhouse that's taking on models 20 times its size on the leaderboards. With this unprecedented level of open intelligence now completely in your hands, the only real question left to ask yourself is, what are you going to build first in the GemmaVerse?